Hey everybody, Mr. Mal here. Going to take you through day 2 of the Unit 7 notes. I know yesterday you guys learned a little bit about monomials, binomials, trinomials, what they were, how to classify them, what each of those looked like, and the degree in which they are, if it's to the second, to the third, to the fourth, what they're called, whether it's quadratic, quartic, cubic, and whatnot. Then you learn how to combine them, add and subtract, and now you're going to learn how to multiply them, okay? So I've got the day 2 notes pulled up here, and I'm going to zoom in on the first thing we're going to do. All right, right at the top it says Learning Targets 3, I can multiply polynomials. Before we really get into that, let's just go through a couple of refreshers. This first one right here, okay? I've got x plus x. Now, if you remember all the way back to your pre-algebra days, this is just like combining like terms. Both of these are the same term. It is 1x plus 1x if they had the coefficients in front of them. Okay, so we would just combine those to get 2x. Okay, if we move on to the next one, 2x plus 3x. Again, these are just like terms. The coefficients are different, but that doesn't mean anything for us. Okay, so we have 2x plus 3x. We're just going to combine those, and we'll get 5x. Okay, what about this next one that might be a little tricky for us? Is we've got x times x. If you remember back to our last unit in 6b, might have even been 6a, we had a few lessons where we had exponents and raised to certain powers, and we would combine them, and when we did, if you remember, we added what those exponents were. In this case, you can't see the exponents, so we can assume that the exponent is 1, right? And if we have x to the first times x to the first, that's really the same thing as combining those exponents, and we can just rewrite that as x squared. Okay, how about this next one? I've got 2x times 3x. This looks just like the second one that we had, okay? But this time there's a multiplication sign in the middle of it. So what I'm going to do is I'm going to take those coefficients, multiply those. I'm going to get 6, and then I have x times another x. That's the same thing as we just saw over here, right? We'll combine those degrees, and it's going to be 6x to the second. Okay, so really we kind of did what we're going to be focusing on today, but let's put it into words and let's describe it. Let's move on down here above this chart where it says, how do I multiply polynomials? Okay, again, we kind of just did it, but if we're going to put it into words, all right, if I want to multiply polynomials, I'm going to start with the coefficients, okay? And what I'm going to do with those coefficients is I'm going to multiply them. So any of the coefficients you have, you're going to multiply the coefficients together. After you've done that, what you're going to do is move to the exponents. Now remember, there may not always be any, and if there is, you can just assume that it's 1. Or if there's not, I should say, you can assume that it's just 1. But anytime we have the exponents, we're going to add them. Okay, so let's give it a shot with this one on the bottom. All right, like I said at the beginning of the lesson, yesterday you guys touched on monomials and polynomials, what they look like. In this case, we have a monomial times a polynomial. We know that because this one only has one term being multiplied by a polynomial, which has 3. Okay? So, how do we go about multiplying them? Well, it's a lot like the distributive property that you guys already know how to do. Okay? You're going to take this term, distributed there, to the middle term, and then the last one. Rewrite each one as you go, and don't worry, before you get overwhelmed, I'm going to take you through step by step how to do it. Rewrite them, combine your like terms, and then you'll have your new final expression. Okay? So let's give it a shot. I'm going to leave my first arc right there because that's the one we're going to try first. I've got 2x to the third times 3x squared. Okay? Remember, go back to the top if you ever get lost. Let's start by multiplying our coefficients. Here, my coefficients are 2 and 3. Multiply those together, I'm going to get 6. Okay? I'm going to make it a little smaller for me. Okay, now I've got x to the third and x to the second. I know my x is going to stay the same, but if you remember, what do I do with those exponents? Okay, I'm going to add them. All right? So I've got 6x and then to the third plus to the second, so it's going to be 6x to the fifth. Okay, so let's go on to the next one. I'm going to take this 2x to the third, and I'm going to multiply it to this negative 4x. Now I'm calling it negative 4 because remember the sign in front of it is negative, so I know that the 4 is a negative 4. Okay, so let's multiply those together. I've got my coefficients of 2 and negative 4, so I'm going to have negative 8. And then I've got x to the third and just an x. Like I mentioned a little earlier, if there is no exponent, we can always assume that that exponent is going to be 1. Remember, that's only if there's a variable, not necessarily for a constant term. Okay? So if I've got x to the third out here and an x to the first in here, I can add my exponents to get 8x to the fourth. Sorry, I'm trying to write with a new stylus here. It's been a little difficult. Okay, so then we're just going to do the same thing with the last one. All right, I've got 2x to the third multiplied by just 5. Okay, so in this one, there's no variable with exponents attached to it, so I can just multiply those coefficients together, which in this case is a 2 and a 5, and my final term is going to be a positive 10x to the third. Now in this case, because there's no added steps for us, I know that I don't have any combining to do with like terms because it's already in descending order, and I don't have multiple terms with the same exponent degree. Okay, so this one is done. All right, so now let's move on to the next one. We have a binomial times a polynomial. Okay, binomial again, because this has two terms. Polynomial is being multiplied by it. And this one has 3 terms, okay? Same thing applies. However, we're just going to have to do the process twice. So we're going to have this 3x going to the x squared, the 6x, and the negative 7. And then we're going to have this negative 4 going to the x squared, 6x, and the negative 7. Okay? I just drew those lines as a visual for you. Don't worry. It's not going to be all that messy when we do it. We're going to go through it step by step. Okay, so let's start with a 3x and the x squared. Okay, so that's pretty simple. I just know I can multiply my coefficients together. I know it's a 3 and a 1. The 1 isn't there, but it is assumed that there's a 1 in front of it. So it's going to be 3x to the third because there's no exponent here, so I know it's a 1. And there's a 2 here. I add my exponent, so I know it's going to be 3x to the third. All right, let's go to the next one. I have 3x times a positive 6x. So that means I'm going to get a positive 18x squared. Add my exponents of the x here and x here, both of them with no exponents, so I know they're 1s. 1 plus 1 is 2, so it's going to be 18x squared. And the last one for the first term is going to be 3x times a negative 7. Remember, don't forget your signs here. I know it's going to be a negative 7 because the subtraction sign is right there. So I have 3x times a negative 7. No exponents to add, so it's just going to be a negative 21x. Okay? Now this is where it can get a little tricky and a little tedious, and why we have so much room here. Because we need to take another term, our expression is going to get a little longer, and that's where the combining like terms comes in towards the end, okay? So let's keep going with this. Now, I've done the 3x each step of the way. I'm going to change my color here, and let's go through and do, try to make it a different color here. Let's do the 4, okay? And let's bring that 4 to the x squared. Now remember, this is a negative 4 because of the sign right there, okay? Negative 4 times x squared. Coefficients are going to be relatively simple for us because it's just a 1 and a negative 4, and there's no x attached to that 4, so it's going to be negative 4x squared. Okay, let's take that negative 4, bring it to the 6x, okay? Sorry, I don't want to write it and get in the way. All right, negative 4 times a positive 6x. Still have to be careful with our signs here. A negative times a positive is a negative, so I know it's going to be a negative term, and it's going to be 4 times 6, which is 24. And there's only one x in the terms. It's on the 6x. Nothing for me to add there, so I can just bring that along with nothing to add. Negative 24x. Okay, and lastly, I have a negative 4 times a negative 7. Simple multiplication right there. A negative times a negative is a positive, so I'm going to get positive 28. Okay? So this is where the combining like terms comes in. Okay? Now for the final one, I'm going to make it a different color. I'll write it in blue. All right? Remember, we want to write it in standard form or in descending order. Okay? I'm going to write over here, just make sure we know we want it to be in descending order. Okay, so I've got 3x to the third. I'm going to go through my lines to see, and all my terms to see if there is another term with a degree of 3. I look in the 18, negative 21, all of these, and I don't see a term raised to the third. So I know I don't need to combine any like terms with that one. So I can write my final expression is going to start with 3x to the third because that is the highest term, and there's no other ones for me to combine it to. So I'm going to have 3x to the third. Okay, now I'm going to look for the next lowest degree. There is a term with an x to the second degree, and there's more than one, so I'm going to have to combine them. Here I have a positive 18x, and here is a negative 4x squared. Okay, so now I'm just going to combine my 18 and a negative 4. I'm going to get a positive 14x squared. So I'm going to rewrite that. I know my 4 is a little messy. 14x squared. Okay? Now I'm going to go to the next lowest degree, which is just x to the first, or x. Okay? I've got a negative 21x here and a negative 24x there. It's a negative 21 combined with a negative 24. Those put together is going to give you a negative 45x. And all that's left over is this 28. Tag that on at the end, positive 28. So your final answer should read 3x to the third plus 14x squared minus 45x plus 28. Okay, let's move on to the next one. This one's a little easier for us because there is a lot less going on. And there is a nice way for us to remember how to do these. Okay, so this is a binomial times a binomial. And the way to remember how to multiply these two together, there's a nice word that we can use, and I'm going to use that to show you guys. We'll write it in, we can keep it blue. We'll write it in blue, and it's going to be the word FOIL. Okay? This is going to help us to remember how to multiply two binomials by each other. Okay? So here I've got binomial x minus 2 and a binomial x minus 9. How I'm going to multiply those together is I'm going to multiply together the first terms, and that's what the F stands for in FOIL. Okay? So first is going to be x times x. If I do x times x, we know that's just going to give us x squared. Okay? The O is going to be our outside terms. Okay, so if my outside terms is going to be x times the negative 9, which will give me my negative 9x. The I stands for inside terms. The inside terms is going to be negative 2 and x. Okay, so I'm going to have negative 2x. And most of you guys probably guessed it, but the L stands for last. So negative 2 times negative 9, which is a positive 18. So now if you see I have all of my new terms after combining these in an order and in the correct order. I need to rewrite these though in standard form so I have a final expression to use. Okay, so I'm going to start with x squared is my first ones. I'm going to write that first because if I look down at all my other ones, that's got a degree of 2. And then no other term has a degree of 2 in it. So I know that that one's going to be my leading term, and it will be x squared. After that, I see I have two terms. Change the color here. Two terms that have x to the degree of 1. It's negative 9 and negative 2. I'm going to combine those like terms which is going to give me 11, negative 11x. Okay? And then finally I have 18, which is just a constant by itself, but it is a positive 18. That is important. Have to carry that positive with it. Okay, I'll write that in a different color as well. I can't really see that one. Okay, so you'll have x squared minus 11x plus 18 as your final answer. Okay, so a lot of it you can remember, especially with the binomial by binomial, by the term FOIL, first, outside, inside, last terms, combine, and then we'll move on to the combining. If you remember, if you look down at example 1, we'll try that one together. Okay, this is going to look trickier, but if you remember, it's the same as if we just do 2x if we had it in the front, because that is the commutative property, okay? But we'll leave it in the back because that's what the example has it, and we'll just go through it the opposite way to kind of show you that it can work either way, all right? All right, so I've got 5x to the third. I'm going to do this the same way I did all the other ones. I'm going to bring that one to just 2x, multiply my coefficients together to get 10, combine my exponent degrees together to get x to the fourth. Okay, now I'm going to do the same thing with negative 6x. I've got negative 6x, that's going to be carried to the 2x, so that's going to be minus 12. Combine my exponent degrees of 1 and 1 to get x squared, and then I'm going to take my 9, carry it to the 2x to get a positive 18x. I'm going to see if there's any combining I could do. There is not. All of the terms have different degrees, so there's nowhere for me to combine. My final answer is going to be 10x to the fourth minus 12x squared plus 18x. Okay, let's go to B. I've got x minus 3 times polynomial of 2x squared plus 3x minus 4. All right? It's not going to be too hard, but it is a little tedious, all right? So let's just start with my first term. I'm going to carry my x. I'm going to bring it to the 2x squared. And if you guys at all get lost here, you can refer to the second example that we did, the one right here. All right, and that's going to take you through step by step the same way we just did this one, okay? When in doubt, just look back up here. Remember to multiply your coefficients and add the exponents. All right, so I'm going to zoom back in. We'll get started on example B. I've got x, that's going to my 2x squared. Coefficients are just 2 times 1, so that's just 2. And then I'm going to get x to the third by adding my exponents. I know it's a 1 for the first term x, and the 2 is shown right there. Okay, now I'm going to take my x, that's going to go to 3x. What is x times 3x? That's just positive 3x squared. And then this is going to go to the last term of negative 4. Negative 4 times x is just minus 4x. Okay, so if you remember, we've still got a little more work to do because we've got one more term we need to carry all the way over to the other one. So this is going to be a negative 3 that is getting distributed to the 2x squared. So that is minus 6x squared. Then I'm going to take that negative 3, bring it to a positive 3x, which is going to be negative 9x, and a negative 3 being multiplied by a negative 4, which is positive 12. Okay, so I've got a really long expression in front of me. I'm going to look for like terms that I can combine and see if I can rewrite my final expression, okay? So my first term right here is 2x to the third. I'm going to look through all the other ones and see if there is a term that has an x to the degree of 3. There is not, so I know that's going to be my leading term. So I'm going to rewrite it here down at the bottom, 2x to the third. Okay? Now I've got a term here with x to the second. I'm going to see all the other terms that have x to the second. There's another one, and that seems to be the only one. That's a positive 3 combining with a negative 6, so my new term is going to be a negative 3x squared. Whoops. The next term to look at is just x to the first, or x by itself. I've got a negative 4 here and a negative 9 here, both with a degree of 1 attached to the x. So that's going to be a negative 4x minus 9x. Combine the negative 4 and negative 9 to get negative 13x. And there's no other exponents to consider, but there is this leftover 12 that we can't forget about. We need to rewrite that at the bottom. So it's going to be plus 12 at the end for a final expression of 2x to the third minus 3x squared minus 13x plus 12. Okay, one more here at the end of the page. Write the polynomial expression that represents the area of the shaded region. Okay, so we know looking at this that this is a rectangle because both of these are different lengths, the side lengths. Whether it was a square or a rectangle, we know that to find the area for it is going to be the length times the width. Okay, well, looking at the sides, I know that these expressions, these binomials that they gave us, are going to express both of those. Okay, so we can just combine those and multiply them together to write an expression that represents the area of the region. Okay, so I'm going to count 2x minus 1. All right, I'm going to consider this the length. Okay, because I know that's the length. I know the length can be represented by the binomial 2x minus 1. And if that's the length, that means this leftover binomial is the width of x plus 2. Here we have our binomial times binomial. We know we're going to FOIL. Okay, first outside, inside, last. Let's start first, 2x and x. That's going to end with 2x squared. Outside terms are 2x and 2. It's going to be plus 2x. The inside terms, negative 1 and x for negative x. And last we have negative 2. From here we're just going to combine like terms. I'm going to zoom in a little bit so I can have more room to write. Okay? I've got 2x squared plus 2x minus 2. I see that this term right here is the only one with a degree of 2, and that is the highest degree. That's going to be my leading coefficient, leading term for the final expression, which is going to be 2x squared. Trying to find the next one. I can see that these both have a variable of x both to the degree of 1. It's not there, but it is assumed that the exponent is 1. So I'm going to combine a positive 2 with a negative 1. That's just going to give me a positive x. Excuse me. Let me make sure I did that right. Carry the 2x. That's going to be, this should be a 4x. Sorry about that. That was our outside terms of 2x times 2, which is 4x. Hope I didn't throw too many people off there. So it's going to be a positive 4x minus 1x, which is going to be positive 3x. All that's left over is our constant of 2. And I'll rewrite that of negative 2. And I'll write that down here in our final term. And our expression will end as 2x squared plus 3x minus 2. Okay, so now you guys have all the notes you need in order to multiply polynomials together. Because this lesson was relatively short in terms of the comparing it to other notes that you guys have been doing, we're going to have you do the practice with this day 2 notes as well today. Okay, so you're not going to do the practice tomorrow. You're going to finish the practice for it today, have that done by tomorrow, or whenever it is assigned, because it might be a little different between Mrs. Russo and Mrs. Schmidt's class. Just take a look at your Canvas page. It'll be outlined there if you have any questions. Be sure to email myself, Mrs. Schmidt, or Mrs. Russo, depending on whatever class you're in. And thanks for watching.